Welcome everyone to the webinar today entitled How Production Scheduling Delivers Big Benefits for Manufacturing. First of all, I just want to give a bit of context, Dassault Systems, and where the applications that we'll talk about today lie in our overall portfolio. We are the 3D Experience company, and we are building a single business platform for manufacturers from design all the way through execution, and right in the middle sits our master planning and scheduling applications. And there are many benefits to the use of this platform. Products, designing your factories and manufacturing process, then transitioning into the simulation of these new processes all the way down to the actual production floor and managing your products with quality and warehouse management and maintenance all on a single platform. You may have seen this icon before and thought it was just a logo of Dassault Systems, but it's actually what we call the compass for the digital experience. In the northern quadrant, you find our collaborative and social applications that allow users to share common KPIs and metrics, to collaborate across business processes, and to do very complex searches even into things like mechanical diagrams and 3D designs to find information pertinent to their role. On the, as we refer to the west, or labeled 3D, is the engineer, and this is where our design applications are found. You may have heard of the brand CATIA, and those applications allow the user to completely design a product and store and share that information with their collaborators. On the southern quadrant, or the V+R, is where the industrial operations applications are found. This would be, in the Dassault world, the applications such as Aprizo and digital manufacturing, which again capture the activity of the shop floor and provide information to feedback back to the engineering and in the east quadrant, the optimized quadrant, where our planning and scheduling applications are found. So if we look a little deeper into the quadrants, again, Collaborate is an empowering application that allows folks to share information, share KPIs, share reporting across any of the functions or activities that take place in your facility. So you could have lean manufacturing metrics, work in process metrics, places where team members could share improvement, continuous improvement data, or just kind of the suggestion box for your company. Right. The engineer section, again, you can see there in the left-hand side of the screen, it's actually a working model of a production facility that's built in the CATIA application that shows how the manufacturing process takes place, whether there are any conflicts with ergonomics and robotics, and you could simulate the safety testing and workability of a particular space to make sure that the human element is taken into account in the manufacturing setup, which is where we'll spend most of our time today, is the planning and scheduling, the dynamic rescheduling when life happens on the shop floor, and the reporting around that scheduling to say, how well do we adhere to our plans? How often are we shipping on time and complete? And how can I use my KPIs, key performance indicators, to drive my schedule and hopefully then the industrial operations. And then finally, we have the operate, which is, again, your shop floor reporting, your quality, and the information, and this is becoming more and more important as we move into an area of industrial IoT, to gather information from sensors in the factory, on the machines, on your autonomous vehicles and fork trucks, and bring that back to a single platform where that information can be then analyzed and distributed, which allows you to build best practices not only for a single facility, but then to publish those on a global platform that allows you to enact them wherever it's appropriate. So why planning and scheduling? We know that many manufacturing companies are on a journey for operational excellence. If we look at the results of this study from LNS Research of where companies are making investments to help them on that journey, you see quality management software at number one. But the second most important investment that people are making are in planning, scheduling, and dispatching applications. Right? So putting a plan together to then execute to a level of performance that is in line with the KPIs that the company is trying to satisfy. But in my 20 years in this space, I've seen a lot of innovation, a lot of investment in new technologies, but when I travel around and speak with folks in factories, I find that a lot of scheduling and even midterm and long-term strategic planning is still being done with tools that have been around for 30 years. And number one of which being just a plain old Excel spreadsheet, right? It's a manual process. Sometimes they're shared on a SharePoint site and groups can collaborate, but there's no integration, right? The way the sheets function are typically dependent upon the experts that build them, and the processes around creating a plan, maintaining a plan, and publishing and sharing the plan are very, very time consuming. In fact, yesterday I spoke to a prospect in the food and beverage industry that is on a legacy process using an Excel spreadsheet, and for a reactive change when apparatus goes down on the shop floor, it takes about 4 hours to reprocess the demand into new work centers using this Excel-based process. But there are engines out there like DELMIA Ortems that automate the entire process, that use sophisticated optimization algorithms to provide the best answer in a given situation. They are collaborative, allowing many users to work on the same planning model, to share ideas, to in their particular needs within a work center or a process, and then in the context of the overall optimization, publish the best answer for the entire facility. So I like to think of these tools as a way to plot your course, right? If you've ever done any hiking or orienteering, you'll recognize this topographical map, and you know that you just typically can't walk in a straight line to where you want to go. It's just not that easy, right? So you need a guide, you need a plan, right? And in today's world, right, if we see where we start, you have this riddle of what's the next thing I need to do, what's the next order I need to process on my machines, right? And that's the first question that any planning or scheduling application needs to solve. And as you work on that riddle, you'll find that oftentimes you have this perception, what I like to call anecdotal perception of how things have worked in the past. So people that have been involved in the processes, reflect on them and give you things like operational time and capacities and stuff. And sometimes that is, and I don't mean this in a harsh way, delusional, because people remember what they want to remember and remember pleasurable things more than they remember painful things. But what these tools allow you to do is to take the data from these operations and bypass this anecdotal delusion, right? So that all of your decisions in scheduling are based on the reality of actual performance or expected performance. And then you can move on as you get some experience with the tools and adjust the metrics, adjust the performance of the algorithm, and have as we see here, a frank appreciation of how the tool is working for you and where that data is correct and how it's allowing you to achieve your KPIs. And then as you get into the tuning phase, you're ready to tackle any challenge that comes along with your 21st century scheduling application. So we're going to take a look at the DELMIA Ortems tool here in a moment and review of the tool. It's capable of doing both long-term planning, capacity planning, sales and operation planning type activities, as well as down to the nitty-gritty moment-by-moment scheduling that takes place on your production shop floor. And it does that by being able to model a variety of constraints at both high, generic, macro level down to very specific, detailed modeling of campaign sequencing and material availability and labor availability and attributes such as that. And what this allows you to do is maximize the utilization of your machines, reduce WIP, and very importantly, speed up the process of just the planning activities. How long does it take to create a plan, to replan, to react to instances and events that happen in your shop floor and in the long-term sense, just in business in general. So let's look at those levels a little bit deeper. So in the long term, what you're really planning is you're matching your expected demand, and in some industries you may actually have long-term demand. In aerospace, for example, you've got orders for aircraft that stretch out for several years. In other industries, long-term can be 6 months, right? It's the velocity of the industry that really dictates what's long-term. But we're matching the capacity versus our available resources. Do we need to add a machine or take a process to a second or a third shift or 24-hour or 7-day-a-week operations? Right? Those are the decisions that you're trying to reach in the long term. In the short term, again, we're looking at production work orders, and we're deciding in what order do they run, on which machine, and what labor resources do I need to deploy to that work center to accomplish those goals. And then finally, Ortems offers what is called here flow synchronization. The module is actually called SRP, or Synchronized Resource Planning, that takes the information across all levels of your bill of materials, right? Generates the work orders, and then uses the optimization engine to tightly link those work orders so you're able to drive down WIP and shorten your lead time and cycle time to produce more finished products in less time without relying on huge inventories. So as we begin to look at Ortems, we look at the functions and features that make it so effective. The first I would mention is that you can manufacture, model any constraint. So whether it be how a machine operates, is it a furnace or a tank which is managed in a batch type capacity? Is it a regular rated machine that runs at 250 units per hour, for instance? What are the different schedules that the machine is open, and that when does your labor shift pattern come into effect? Do you have the materials in the right place at the right time? You can take all this information and then play around or solve problems in a what-if mode. So, you know, what if a critical delivery that's scheduled for today doesn't show up, right? Maybe it won't affect me today, but will I have the material to have production tomorrow? What if, for instance, a very critical machine goes down? Are there alternative methods of production? Which orders should be reprioritized? Where can I fit that order back in, given the details that, say, our maintenance or shop floor personnel tell us when that machine could be fixed? And then again, last, it's a collaborative tool, so you don't have to rely on a single person trying to fix the problem. You can have multiple people taking different approaches and then deciding what's the best way to continue your manufacturing. So we looked at it earlier at the different levels. This, from an application perspective, gives you a bit of how the landscape looks. On the left is the production scheduler, which again is the short-term detailed optimization engine. And on the right is the manufacturing planner application, which again is more of a level loading or capacity management system. They work off of a common data model. So if you had needs for both scheduling and planning, you don't necessarily have to gather two separate quantities or detail level of data around your processes. The algorithms that are invoked by the two modules are different, but the underlying data is the same. It just differs in the level of granularity. So often we'll have folks who have aims to be very detailed in their production scheduling, but not yet have the data at enough detail to generate a schedule. So we'll actually start with the manufacturing planner model that then becomes more detailed and more detailed until we're able to transition it to a scheduling environment. So back to the application and trying to get a handle on the look and feel. Most sessions, we're going to see a lot of Gantt charts and bar graphs and things, and these are all configurable for your users and unique to their roles. You can save desktops, you can attach soft keys to them, so with one touch they're able to bring up the information that they require. I've talked already about what-if simulation, but I can't stress that enough. It's the way to make sure through what-if simulation and comparing your simulations that you're getting the right answers. You're able to do both forward and backward scheduling, and that has different levels of interest for folks in different industries, or if you're manufacturing just in time, right? Sometimes backward scheduling gives you the best answer. Typically, most folks schedule forward, maybe on a key resource they might do a little backward scheduling, but those are all answers that our consultants work with you on once we're in an implementation. And then finally, to address this slide, you can run these scenarios and solvers in both finite and infinite capacity. Right? Finite, we know, is the real world. That's where we want to be before we publish a schedule to the shop floor. But in scenario mode, you may want to run on infinite capacity and just see what the load is across your facility before you put the constraint of labor or a particular machine, before those are invoked. Right? So then you can say, well, maybe I do need to add a shift, or I do need another lathe or milling machine or a 3D printer. Again, views of Ortems are, to me, very intuitive. Gantt charts, everyone has probably worked with them at some point in your career, even if it's only on Microsoft Project, but it's the similar concept. You see how a resource is allocated through a time horizon. In the case of our screens, that time horizon is completely flexible from minutes to hours to days to shifts to weeks to months, and in long-term views even to years, and you're allowed to build your own custom time units. These Gantt charts are completely interactive. You grab an allocated operation to a machine, you can drag and drop it to any other suitable machine based on that operation, and in fact the application itself tells you what the suitable machines are through highlighting the screen. And I like to say that I can teach someone in a planning role how to use the basic Gantt chart in less than a week. It's that intuitive and it's that easy to understand. So when we look at what we can model in Ortems, that includes, of course, the machines that you have on your shop floor, all of the labor resources, and that can be general just in terms of the number of operators that are available on the shift. You could take it down to a skill breakdown of, say, mechanical technicians that are able to do changeovers on machine versus the normal operator. You can in fact get down to very precise skills management where you are actually modeling the labor resource by name. So Matthew Baird, myself, am a chemist level 3, and I can work on some kind of process control activity, for instance. Or I am a 3D printing expert that has to be assigned to a group of 3 machines anytime they're operating. Again, we can manage all of your inventory as part of the planning process. Do I have the raw materials available? Where are the semi-finished products and sub-assemblies? Are they going to be ready in time for final assembly? Do we have materials coming in from outside, and when are they due? Or if we're looking out over the course of several days to several weeks, do I need to make any purchase recommendations back to my procurement engine to say, hey, I've changed the schedule, we need material a day earlier, is that feasible? And of course, things as simple as managing the setup time between disparate operations on the shop floor, whether that be color sequences, size sequence, material changes, all of that can be modeled in the application. So we talked a little bit about Synchronized Resource Planner earlier. Just to give you a bit of a view of how that looks in the screen, and in this case, all of the linkages between a set of work orders to produce one final assembly order are highlighted. I like to call this bit of functionality, the whip killer. And that's because you're able to tighten up the latency between operations so that as a lower level work order is complete and you're going through your semi-finished or sub-assemblies up to final assembly, you're able to tighten up that time that a material is just waiting for the next process. Right? And you can include things like quality control checks, if you have to heat treatment or any type of activity that may cause the material to be out of use for a bit of time. So if you heat it and it needs to cool for an hour, you can model that in as a timeout after the operation. But the algorithm inherently wants to compact the residence time of that process. So from the time you start the very first operation till you complete the final assembly or the final piece of production, we want to do that as efficiently as possible, utilizing the machines that best meet your KPIs: lowest cost, highest rate, fewest labor resources. That's your decision, but then the SRP will then calculate the best answer based on those criteria that you configure. I mentioned it earlier, but again, this is a very powerful feature to be able to define KPIs, min, maxes, and targets across a number of KPIs, to invent your own KPIs, and then manage the results of your scheduling against those KPIs and say, what if I did X versus what if I did Y? How does that affect the KPIs? And as you can see here in the lower right, we actually can even step through the KPIs and see graphically how the different simulations are evaluated, and then decide, in this case we have 4 simulations, which one do we want to invoke as the schedule that's going out on the shop floor. Now, I know we might have some IT folks in the audience, and they always say, that's great, it's a wonderful application, but where does it get the data it needs? How hard is it going to be to manage this, this application? And you know, how is it going to change my IT landscape? So yeah, there's information that Ortems needs from other systems. Typically those are going to be ERP applications, such as SAP, Oracle, or the MES applications like our Aprizo or other providers' systems. But we have a lot of experience, over 20 years of experience providing the Ortems solution before we were acquired by Dassault. And so we've pretty much worked with everybody. We've got certified adapters. We've been certified with SAP since the mid-90s. We've already been certified on SAP HANA. We provide scheduling engines for companies like Sage and Microsoft Dynamics. But I think the important thing to take away is that no matter what systems you have, we've probably already done some work with them. As it says here, 150 plus. I think the number is actually 160 something now. Systems not related to Dassault, right, that we've integrated with before. And the principal way we do this is with a tool that we provide called the Visual Interface Configurator, or VIC. And what this allows you to do, it's a very simple ETL engine, or extract, translate, and load for the non-technical folks. So I can take data from a system, map it to the appropriate fields and tables in Ortems, run those jobs, say for an initial import and implementation, but more importantly, on items like the feedback from the shop floor, what production has actually been accomplished, or new orders from the ERP system. I can build jobs that allow that information to flow between the two systems in an automated fashion. So every night at 2 o'clock in the morning, go find all the new work orders generated by SAP or your other ERP system. And oh, by the way, every 15 minutes, talk to the MES system and see what's been produced, if any machine has been declared down for maintenance, etc., and bring that back to scheduling. So the ability to get data in and out of Ortems is not a major concern for our customers. I've talked about collaboration several times. It's important in today's world because, for one, facilities are getting larger and larger with more work centers under a single roof, and you typically have more planners and schedulers working together. We're also getting away from the kind of one brain controls everything. Again, as I said, some of that anecdotal evidence and anecdotal perception, and if you spread the planning and scheduling out for a group, I think you get a better answer because people are more familiar with certain constraints and capabilities than a general environment. So being collaborative, being able to allow multiple users in a single model, which is very important, and then selecting from the different moves and adaptations, that those authorized users make to reach a final plan is very important. A typical scenario that happens probably every day in your plant, it happens every time I go visit a facility, usually right in front of me for some reason, that you go out on the shop floor and the first thing, the supervisors and key personnel may get together with the plant superintendent or the operations manager, right? And we have our quick fast five meeting, what needs to be accomplished today, what are the key things that we're going to look for, what are we expecting to happen today. So there's going to be a tour, and the guy from the DELMIA Center of Excellence is going to come nosing around to see how he can help us, right? And then everybody's out to the shop floor, right, and begins to execute on those orders. But it's real life. Machines break, materials are late, or they are not up to a quality standard, and things happen, right? So what do you do about it? In this case, we're going to say that we've had a problem on the shop floor. My cutting tool is broken. Here, this is a Prezo screen or a MES screen. The operator can identify the issue, raise a maintenance alert, create an order to have someone come check out the machine and see if there are replacement parts or a quick repair. Let's say the maintenance person says the part can't be repaired and we don't have any in stock, and it's going to be a day, 2 days before we can get a part in from our supplier. So let's notify the folks in scheduling, right? They can then enter that downtime, right, and re-optimize the schedule, which could mean moving orders to another machine, investigating whether another process can accomplish the same work. And what do we do with the human resource that was assigned to that work center? Is there another place to utilize them while that machine might be down? Okay. So other scenarios where there's interaction between different applications and Ortems, the typical production reporting, what's being made, where are we in shop floor. Again, this is an Aprizo MES screen, but as you can see here with those updates, here on the left you see kind of the caution bar or work in progress bar of the black and white stripes saying, okay, we've gotten feedback from the shop floor, this much work has been accomplished, and now let's update those and we can republish new start times for the other work that's following along behind it. Another scenario, let's say you have material inspections, either raw materials or semi-finished materials that come to a line, and you have an inspection plan that's in the MES, right? But maybe you want to share that information with a larger audience. So the production control folks, customer service folks, any number of roles can be involved. You can highlight the fact that there's a new inspection process. In this case, we use what's called a marker on this particular job running on mill 1. And when we look at the details of that operation for the toothed ring on mill 1, we see here a message that there's a new inspection process. Has it been inspected? No, it still needs to be inspected. And as that work is completed, they can switch the marker to say the inspection is complete. The color will change on the graphical view, and again, at the same time, that action that takes place in Aprizo is available to the larger audience of folks concerned with manufacturing. And then the final scenario we'll talk about has to do with quality. So, many times you have folks with certain skills or certain certifications that you want to be involved in your production. So why leave that to chance when in the planning engine you can actually use, again, what we call nominative ladder management. So as people accumulate skills and progress through various levels of competency, that makes them eligible to perform certain operations on certain machines. We can actually use that information to plan them as individuals and make sure that they are assigned to those operations on those machines at the right time. And if they have a number of skills, they can move around where they are most needed or where their skill represents the most in-demand skill. So they need to be scheduled first to the right job before they perhaps get assigned to a task that others could perform. Just again to show you how Ortems fits into the landscape here, it's this box on the upper right doing your planning and scheduling, and again that's sales and operations planning all the way through short-term detailed scheduling. And really the important thing, other than the fact that Dassault offers you the design, the digital manufacturing, and manufacturing operations management, is what that then allows the ERP to do is what it's good at, which are the financial operations of the company and maintaining the master data around your processes, your items, your bill of materials, and your routings. Right? That's the information we need in order to give you an optimal schedule. So when you look at that across the entire landscape, so if you were to integrate Ortems with your digital manufacturing application or your product lifecycle management application, what that allows you to do is do simulations around new product introduction and balancing the shop floor load based on the new materials that may be coming into the plant. When you're integrated with the manufacturing's operation management or an MES system, it gives you an automated advanced rescheduling optimization when things happen on your shop floor, right? And then integrated with your ERP gives you long-term MPS and detailed scheduling capabilities. We'll quickly talk about a couple of customers and then we'll get to your questions. Again, Ortems has been around for over 20 years. We've got hundreds of customers across a variety of industries. Here we're highlighting the 6 industries where we have the largest complement of customers. So aerospace and defense, transportation and mobility, industrial equipment, high-tech, and consumer products, and life sciences. I'm sure you'll recognize many of these names, but let's dig into a little detail around a couple of customers. So Novaris, you may not know that name because it's recently changed. It was Mecaplast in Europe and Key Plastics in the Americas. They're a supplier to, I think, about 14 different automobile companies, and they do the injection molded plastic, interior and other plastic parts. They've been a very good customer for Ortems for quite some time. They are our model for a large deployment. Right now they're at 23 sites and still going. The story there that's, I think, interesting is in the first site, the prototype, it took about 5 months of consulting time to do the implementation, and through the iterations from that core model that we built at the first site, we're now down to a deployment takes about 3 weeks or less of consulting time, because basically we're taking the knowledge that's gained over the previous implementations, replicating that where pertinent, and then just whatever is unique to a particular facility is then added in. So they're getting quite the value of an economy to scale. And then when you look at what they've been able to accomplish, about a 40% WIP inventory reduction, their service level consistently exceeds 98.5% and as often as 100. Their suppliers are able to supply them more efficiently because the schedule is stable and they have visibility to it, and they know what their commitment needs to be to supply Novaris. And as we see in many places, just the time to generate a schedule and get something out to the shop floor is reduced tremendously. And that can go from 1 day down to 30 minutes to the example I had today, 4 hours down to nearly instantaneous. But it's a major effect that Ortems has on the planning and scheduling personnel. Another highlighted customer is Solvay, the chemical producer. Again, we have 5 sites with over 50 users. They've been able to reduce their changeovers by 20%. They're better able to manage their maintenance, and one of the key scheduling components is they actually have a prioritization of machines for each process, and through the intelligent planning, they are much better able to get the right operation on the preferred machine. And then there's quite a number of testimonials, and you can see some of the customers' names there, but what you will see is work in process inventory is down from 20 to 45%. The scheduling time reduced typically by half, if not more. the ability to not have to do expedited shipping or work overtime. And we're going to share this presentation with all of you afterwards, so you can dig into the particular details that interest you in these benefits. So to kind of wrap up, what do you get out of implementing Ortems? The better ability to meet your commitments with your customers, ability to reduce lead times and inventories, an increase in throughput and asset utilization, and the planning processes, long-term through detailed scheduling, are reduced to at least half of what they typically are with legacy means. That's it for me.
Everyone, thank you very much for joining today, and have a great day. Thank you.